Hello everyone. Welcome to Tech with Kaushik. Today, we are going to explore one of the newest Microsoft certification exams, AI-200, the Azure AI Cloud Developer Associate exam. This is not going to be a basic overview. We are going to understand what the exam is really testing. We will look at the important services. We will compare AI-200 with AZ-204. And most importantly, we will learn how to think through exam scenarios. I have also created a complete AI-200 study guide PDF for you. The download link is available in the video description. So, download the guide and keep it with you while watching this video. By the end of this session, you will have a clear preparation roadmap. You will also understand the architecture mindset behind the exam. Let us get started. First, what exactly is AI-200? AI-200 is the Azure AI Cloud Developer Associate exam. It is designed for developers who build AI-enabled cloud applications on Azure. But here is the important point. This is not only an AI theory exam. And it is not only a traditional Azure developer exam. It combines cloud development, AI integration, application hosting, data architecture, messaging, security, and observability. The exam expects you to think about the complete production system. Where will the application run? Where will the data live? How will the application retrieve context? How will messages move through the system? How will you secure the solution? And how will you monitor and improve it? That complete system mindset is the heart of AI-200. So, why is this exam important right now? Because the way applications are being built is changing. Companies are no longer interested only in AI demonstrations. They want real AI products. They want applications that can scale. They want applications that are secure. They want reliable data retrieval. They want event-driven processing. And they want strong monitoring and troubleshooting. This creates a new type of developer role. A developer who understands both cloud engineering and AI application delivery. That is exactly where AI-200 fits. It validates that you can take an AI idea and turn it into a production-ready Azure solution. Because the exam is new, early candidates also have an advantage. You can build your knowledge and certification profile before the market becomes crowded. Now, who should prepare for this exam? The first group is Azure Cloud developers. If you already build web applications, APIs, or cloud services, AI-200 is a natural next step. The second group is AI application developers. If you connect AI models with application data, APIs, and user experiences, this exam is highly relevant. The third group is AZ-204 certified developers. You already understand Azure development. Now you can upgrade your skills toward AI production architecture. The fourth group is platform and DevOps teams. If you manage deployment, scaling, security, and observability for AI workloads, this exam can also be valuable. However, this may not be the best first exam for someone who is completely new to Azure. You should first understand basic cloud development before moving into AI solution architecture. A very common question is this: how is AI-200 different from AZ-204? AZ-204 focuses on general Azure application development. You learn how to build, deploy, secure, and monitor cloud applications. AI-200 starts from a similar foundation, but it shifts the focus toward AI-native cloud solutions. In AZ-204, the main question is often, how do I build this Azure application? In AI-200, the question becomes, how do I build this complete AI system? That includes container runtimes, vector databases, retrieval patterns, event-driven AI workflows, security controls, tracing, performance tuning, and operational troubleshooting. So, AI-200 does not make your AZ-204 knowledge useless. It builds on that foundation. Then it moves you toward production AI architecture. If you have already passed AZ-204, you are in a strong position. You do not need to start again from the beginning. Keep your knowledge of app service. Keep your understanding of Azure functions. Keep your identity, storage, deployment, and messaging fundamentals. Then add the deeper AI-200 topics. Learn container apps and AKS more carefully. Understand vector retrieval. Learn Cosmos DB vector scenarios. Understand PostgreSQL with PG Vector. Study Redis caching patterns. Learn OpenTelemetry. Practice KQL. And understand how AI workflows are monitored and troubleshoot. Your goal is not to replace your Azure developer knowledge. Your goal is to expand it. You are moving from cloud application development to AI cloud solution delivery. The exam blueprint can look like a long list of Azure services, but do not study it as a random list. Instead, organize the exam into 4 major questions. Question 1. Where does the AI application run? Question 2. Where does the application data and context live? Question 3. How do events, messages, and workflows move? Question 4. How do you secure, observe, and improve the system? These 4 questions create a complete architecture map. Once you understand this map, individual services become easier to place. Container apps belongs to Runtime. Cosmos DB belongs to data. Service bus belongs to reliable messaging. OpenTelemetry belongs to observability. This is much easier than memorizing every service separately. To make the blueprint easier to remember, use the Core 4 framework. C means containerize. O means organize data. R means react and connect. E means enforce and explain. Containerize means choosing the runtime, deployment method, and scaling model. Organize data means choosing databases, vector stores, caching, and retrieval patterns. React and connect means managing events, messages, functions, and orchestration. Enforce and explain means applying security, observability, troubleshooting, and performance tuning. Whenever you read an exam scenario, place it into one of these 4 areas. That immediately reduces confusion. Instead of asking, which Azure service name do I remember? Ask, which system problem is this question testing? That is the smarter way to approach AI-200. Runtime selection is one of the most important exam topics. You need to understand app service, container apps, and AKS. App service is usually best when you need simple, managed web application hosting. It offers a straightforward deployment model. Container apps is strong for containerized APIs, microservices, event-driven scaling, and revision management. It gives you many container benefits without requiring full Kubernetes management. AKS is appropriate when you need deep Kubernetes control. Use it when the scenario requires cluster-level control, advanced orchestration, or custom Kubernetes configuration. Here is the key exam lesson. Do not automatically choose the most advanced service. Choose the simplest service that fully satisfies the requirement. More complexity is not automatically a better answer. The data layer is critical for AI applications. A normal application stores data. An AI application must also retrieve the right context quickly and accurately. The typical flow looks like this. The application receives a request. It creates or uses embeddings. It searches a vector database. It retrieves relevant context. That context is added to the prompt. Then the AI service generates the response. Cosmos DB is useful for globally distributed application data and vector search scenarios. PostgreSQL with PG Vector is useful when relational data and vector retrieval must work together. Redis is useful for fast caching, session context, and hot path acceleration. The exam will often test the balance between retrieval quality, latency, simplicity, and cost. Now let us follow an event through an AI application. The process may begin with a user or an application request. That request reaches an API or Azure function. The application may then send a message to Service Bus, or it may publish an event through Event Grid. Workers or orchestration components process the task. The workflow may call an AI service. Finally, the result returns to the user. The important concept here is decoupling. The user-facing application should not always wait for every background task to finish. Messaging allows components to work independently. It also improves reliability and scalability. In exam scenarios, pay attention to words like queue, retry, notification, trigger, workflow, and orchestration. Those words often reveal the correct architecture pattern. A production application is never finished after deployment. It must be secured, it must be monitored, and it must be improved. Identity and access control determine who can use each resource. Managed identity reduces the need for stored credentials. Key Vault protects secrets and certificates. App configuration separates operational settings from application code. Observability provides metrics, logs, and traces. Troubleshooting helps locate failures. Performance data helps improve latency and reliability. Think of this as a continuous feedback loop. Secure the application. Observe what happens. Find weaknesses. Improve the system. Then continue monitoring. AI-200 tests this full operational lifecycle. These 3 services are often confused. Let us separate them clearly. Service Bus is a messaging service. Use it for reliable queues, retries, buffering, and asynchronous processing. It is a strong choice when work must not be lost. Event Grid is an event routing service. Use it for lightweight notifications, fan-out, and near real-time event distribution. It tells other services that something happened. Azure Functions provides event-driven compute. It runs code when an event or message arrives. So remember this simple rule. A queue points toward Service Bus. An event notification points toward Event Grid. Code execution triggered by an event points toward Azure Functions. Many architectures use these services together. but each service solves a different part of the workflow. When the exam mentions container apps, think beyond basic deployment. First, you build the container image. Then you store and version it in Azure Container Registry, or ACR. Next, you deploy the image to container apps. Ingress controls how the application is exposed. Revisions allow you to deploy a new version safely. They also support traffic splitting and rollback. KEDA helps scale the application based on events or workload signals. And troubleshooting requires checking logs, startup errors, environment variables, and configuration. The exam may test the entire container lifecycle: image creation, registry storage, deployment, revision management, scaling, and runtime troubleshooting. That complete flow is more important than memorizing only the deployment command. Now let us compare 3 important data choices. Cosmos DB is a strong option for globally distributed AI-ready application data. It supports flexible data models and vector search scenarios, but you must think carefully about partitioning and cost. PostgreSQL with pgvector is strong when relational data and vector data must stay together. It provides familiar SQL with vector retrieval, but query design and performance tuning still matter. Redis is strong for extremely fast access. It can support caching, session data, and frequently used context, but you must manage cache freshness and invalidation. The best exam answer will not only store the data, it will match the retrieval pattern, latency requirement, application model, and operational cost. Security should be built into the architecture from the beginning. Managed identity allows Azure services to authenticate without hard-coded passwords or keys. RBAC provides role-based access control. It helps you grant only the permissions that are actually required. Key Vault protects secrets, certificates, and sensitive values. App configuration separates configuration settings from application code. Network boundaries reduce exposure. Private connectivity and controlled access can protect important resources. In many exam questions, several answers may technically work. The stronger answer often uses managed identity and least privilege. Avoid stored credentials whenever possible. Protect secrets centrally, and reduce unnecessary network exposure. Observability must cover the complete request path. A user sends a request. The request enters the runtime. The application accesses data. It calls an AI service. Then it returns a response. Every stage should emit useful telemetry. OpenTelemetry provides a standard way to collect traces, metrics, and logs. Application Insights helps track performance, failures, and dependencies. Logs and KQL help investigate incidents. You can search for errors, slow requests, failed dependencies, and unusual patterns. Observability also provides tuning signals. Latency may reveal a slow retrieval step. Failures may reveal an incorrect configuration. Usage patterns may reveal where caching is needed. You cannot improve a system that you cannot see. Microsoft exam questions often hide the answer inside the requirement. Look for workload signals. Full Kubernetes control usually points toward AKS. Containerized microservices with simpler management usually point toward container apps. Asynchronous, reliable processing points toward service bus. Lightweight event routing points toward event grid. Relational data with vector retrieval points toward PostgreSQL with pgvector. Globally distributed AI-ready data points toward Cosmos DB. The service name is not the most important thing. The workload pattern is the key. Train yourself to translate scenario language into architecture requirements. Once you recognize the pattern, eliminating wrong answers becomes much easier. Here is a practical 4-week preparation plan. During week 1, understand the exam structure. Review app service, container apps, AKS, and your AZ-204 fundamentals. During week 2, focus on the data layer. Study Cosmos DB. Study PostgreSQL with pgvector. Study Redis. And practice retrieval architecture. During week 3, study eventing and security. Focus on Service Bus, Event Grid, Azure Functions, Managed Identity, and Key Vault. During week 4, focus on observability and revision. Study OpenTelemetry, Application Insights, KQL, troubleshooting, and performance tuning. Finish with mock scenarios and small practical projects. Do not only read documentation. Turn every service into a decision rule. Practical projects will make your preparation much stronger. Project 1. Containerize a simple AI API and deploy it to container apps. Project 2. Create a vector retrieval demo. Store embeddings and retrieve relevant context. Project 3. Build an event-driven AI workflow. Use messages, triggers, and background processing. Project 4. Create a secure deployment. Use managed identity, key vault, and separate configuration. Project 5. Create an observability dashboard. Trace requests and monitor performance. These projects do not need to be large. A small working demonstration is enough. The goal is to understand how the services connect. Hands-on work turns exam theory into practical understanding. Let us review 5 common exam traps. Trap 1 is name matching. Do not choose a service only because the name looks familiar. Trap 2 is model-only thinking. AI-200 tests production systems, not only AI models. Trap 3 is single metric bias. Do not optimize only for speed. Balance quality, latency, simplicity, reliability, and cost. Trap 4 is ignoring security. Managed identity, RBAC, and key vault may be essential parts of the answer. Trap 5 is deploy and forget thinking. Deployment is only the beginning. You must also consider revisions, scaling, monitoring, and troubleshooting. Wrong answers often solve only one part of the requirement. The best answer solves the full production problem. For AZ-204 certified developers, the transition is very logical. Your app service, functions, and API knowledge becomes a foundation for choosing AI runtimes. Your general database knowledge expands into vector search, PG vector, Redis, and AI-ready data design. Your messaging knowledge expands into event-driven AI workflows and orchestration. Your deployment knowledge expands into security, observability, tuning, and troubleshooting. So, this is not a complete restart. It is an upgrade. Your existing Azure knowledge is a major advantage. Now you need to add the AI production architecture mindset. Focus on the new decision areas. Do not waste time relearning topics you already understand well. Before the exam, review these 5 areas. First, runtime. Can you explain app service, container apps, and AKS? Do you understand ACR, ingress, revisions, and scaling? Second, data. Can you explain Cosmos DB, PostgreSQL with PG vector, and Redis? Third, eventing. Do you understand when to use service bus, event grid, and functions? Fourth, security. Can you explain managed identity, key vault, app configuration, and RBAC? Fifth, observability. Do you understand OpenTelemetry, application insights, KQL, latency, and troubleshooting? Try explaining every topic without notes. If you can explain the decision behind each service, you are close to exam ready. Here is a useful exam day technique. Before you begin answering questions, write down the core 4 memory map. C. Containerize. Remember app service, container apps, AKS, ACR, ingress, revisions, scaling, and troubleshooting. O. Organize data. Remember Cosmos DB, PostgreSQL with PG vector, Redis, latency, and partitioning. R. React and connect. Remember service bus, event grid, functions, and orchestration. E. Enforce and explain. Remember managed identity, key vault, RBAC, OpenTelemetry, KQL, and tuning. This is not a trivia list. It is a mental map. When a question feels confusing, return to the map. Identify the workload pattern. Then choose the service. Let us bring everything together. A complete AI solution begins with the user or application. It runs on the correct runtime. It retrieves context from the right data layer. It uses messaging and events to connect the workflow. It applies security and observability throughout the system. Then it produces the AI output. That is the architecture mindset behind AI-200. Remember the core 4 framework. Containerize. Organize data. React and connect. Enforce and explain. Think like a production architect. Do not think like someone memorizing random service names. AI-200 rewards developers who can turn AI ideas into deployable cloud systems. The complete AI-200 study guide PDF is available through the download link in the video description. Use it for your preparation and final revision. If this video helped you, please give it a like. Subscribe to Tech with Kaushik and enable notifications so you do not miss future certification videos. Also, share your preparation status or your most difficult AI-200 topic in the comments. Thank you for watching. Good luck with your preparation, and I will see you in the next video.